Welcome back, Algebra 2, back to tests and the lovely videos. So we are starting on the Chapter 5 study guide today. So we're just going to dive in with number 1. So number 1 says, given the functions f of x is equal to 3x minus 5 and g of x equals 1 minus 2x squared, find f of g of x, then find its domain. So remember, f of g of x, we can rewrite it if it helps you to visualize it a little bit better. We can rewrite it like this. And so what that's telling me is that's saying into my function f, so into 3x minus 5, wherever there's an x, so here, we're going to be plugging in 1 minus 2x squared, which is g of x. So into f, we're going to plug in g of x. So the 3 stays the same, but instead of writing x, we're now going to write 1 minus 2x squared. And then minus 5. Okay, so we are just going to distribute 3 minus 6x squared minus 5. I'm going to combine my like terms, so 3 and negative 5. So combined and simplified would be negative 6x squared minus 2. Now at this point, this is all you are doing. You are just finding this new function. You're not solving for anything. You are not factoring. You are essentially just getting the function as simplified as possible after you plugged it in. So this would be my answer. And you don't have to write the f of g of x. I'm fine if you were just to write negative 6x squared minus 2. Okay, so the second part is finding the domain. Now this one, the domain, is kind of easy because if you notice, so we first have to find the domain of negative 6x squared minus 2. So if we are, if we want to write our thought processes out here, if we look at negative 6x squared minus 2, well, negative 6x squared minus 2 is a polynomial. And we know that a polynomial, the domain, is always all real numbers. But don't forget that when we are finding the domain of f of g of x, not only do we have to find the domain of negative 6x squared minus 2, but we also have to find the domain of g of x, the function that we plugged in. So we also have to look at 1 minus 2x squared, which fortunately enough is also a polynomial. And just like before, a polynomial, the domain is always all real numbers. So my domain here is just all real numbers. Do you need to write this out on your test? If they were both polynomials, no. So just, so you can see my thought processes there. And that does it for number 1. Okay, so for number 2, number 2 is pretty similar. It's just a little bit more complicated because it's asking us the same thing. It's asking us to still find f of g of x. But what makes it more difficult is that g of x, what we're going to be plugging into f, which is x plus 1 over x minus 1. Wherever there's an x, which is here and here, we need to plug in 1 over x. Okay, so into my function f. So instead of x, we are going to write 1 over x and then plus 1 all over, and instead of x, 1 over x minus 1. Okay, so at this point, that's like, you know, half of the problem, right? Is just actually plugging it in. So now that you've plugged it in, it looks a little blurry, so I'm going to try and focus it. Once you've plugged it in, what you need to do is simplify. And so if you notice, we have a fraction on top and a fraction on bottom. And so what we want to do is get it so there's only one fraction. And so that means that we need to get one fraction on top and one fraction on the bottom. Now, there are so many different ways that you can do this. Typically, I show you guys splitting it up and then dealing with the top and the bottom totally separately. Today, I'm going to show you just a different way since you can, you know, you've been seeing me do it the same way over and over. So I'm just going to show you a different way. It's similar in nature, right? Because we're still doing the same thing, but it's just a little bit different method. So the first thing I do is I notice, so I have a fraction here and I have a fraction here. So I'm going to write it over 1 just to remind myself that I can only add these if I have a common denominator. So to both of those, I put them over 1 just to remind myself. And so I want to combine 1 over x and 1. And so the only way I can do that is with a common denominator. So I am going to multiply this by x over x. And then I look down here, same thing. I need to multiply, it's x and 1. My common denominator is going to be x. So I'm going to multiply it by x over x. Okay, so I now have 1 over x plus x over x, all divided by 1 over x minus x over x. Okay, so if we look at the top, now we have a common denominator. They both have x in the denominator. So what that means is we can combine the numerators by adding. So we would have 1 plus x over x. And then the bottom, they now have a common denominator. So we can combine those two. So it would be 1 minus x over x. So at this point, there's a lot of different ways that you can kind of go about this. You can know, if you're like really comfortable with fractions, you can know that, okay, both the denominators are going to cancel out because they're the same. Or if you want to separate it out like we do and rewrite it as 1 plus x over x. And then remember, this is the same as division. So we can say divided by 1 minus x over x. And then we know to divide fractions, we have to multiply and then take the reciprocal. And so what happens, just like I said up here, is these x's are going to cancel out, and my final answer is going to be 1 plus x over 1 minus x. Now, trick question, can these 1's cancel out? No. Can these x's cancel out? No. Right? There's a plus in between, which means we cannot cancel them out. There's a subtraction in between, which means we cannot cancel it out. So that means that this is my answer. F of g of x is equal to 1 plus x over 1 minus x. Okay, so now is on to finding our domain. So we have two functions that we need to look at for our domain. The first one I am going to look at is our result that we got here. So 1 plus x over 1 minus x. And that is a rational expression, which means fraction, right? Fraction, rational, same type of thing, except what rational means is that we have a variable in the denominator. Now we know with fractions, we can never have a 0 in the denominator. So we need to figure out what value is going to make our denominator 0 so we can count it as an excluded value. So we would go 1 minus x can't be equal to 0, subtract 1, divide by -1, and we get x can't be equal to 1. Okay, So that is my first one, right? So we include that. For all x values, x can't be equal to 1. But don't forget, you also have to include the domain of g of x, which is the function that we inputted into our original function. So we have to look at the domain of 1 over x, which is also a rational expression, which means we have to set the denominator, which is x, and x can't be equal to 0. It's already solved, so we just would go 1 and 0. And that is my domain. So remember, the domain, you find it of the new function, and then you also have to find it of whatever function you plugged in. Now in both of these cases, it was g of x. If we had plugged in f of x into g of x, you would have to find the domain of f of x. So whatever is being plugged in, you also have to look at that domain. Okay, that does it for 1 and 2. I am going to start number 3 on a new video.